Hello, everybody, and welcome to our fourth webinar in this series with HP Robots Otto. For the ones that maybe were not in the previous one, I invite you to go to the link in the chat, hprobots.com/webinars, where you can sign up to watch the previous one. You don't need to watch those ones to know what is going on here. We will be doing a little bit of connection between like things that we talk in other ones, but pretty much everything, it's all interconnected to the information we have in the website and things that we present. So today it's a big topic that many people were requesting. I know many of you would like to see what we have been working behind the scenes in terms of AI and IoT and Python. So of course, now the topic trendy is AI. Everybody's talking about it, how robots are going to replace us, etc. And we have robots here, so it will be an interesting topic to discuss together with you today. As a little agenda for you to know what we'll be talking today, first we do the intro and welcome. We will jump immediately to our special guest that has a surprise project that he has been working on that it's very relatable with ChatGPT, so many of you will find interesting. And after that, because we have a couple of extensions and things connected with artificial intelligence, we will have a break Q&A for you to just start to ask about those things. But we will continue. It's not going to be the end of the webinar. This is just to have something in the middle, so like it's not tiring always me talking and like just you watching me saying all the stuff and presenting, but also so like you're welcome to participate. In case you want to talk to us, you can unmute in the moment, or you can just post the questions in the chat. So anytime you have a question, remember you can just put it in the chat, and we will go through them in the Q&A session, or by the end we will have a last one in case that you have following questions for the other topics. So we will have also simple examples of IoT with Otto, like connecting to the cloud and how we can get potential of the Wi-Fi chip that Otto has for different interactions with the internet. A little bit of Python examples that we have been doing here in the office that you will find interesting, how we can use these new chats that allow us to basically create code for us, and how can we, with little smart prompts, we can combine it with Otto, and it will be very useful for teaching coding to kids, because it's gonna be the new way to really interact with code, is to use AI as your assistant. So we will have a little bit of that, and the prompts for designing. So for example, the image that you see there, it was AI generated based on an image we created. So we will give a little bit of tips how you can create images like this that later can be used for either just content or lessons, or we could use them as well for designing our own modifications of Otto. And yeah, and with that we will close for the next webinar. That will be the last one. So just for you to know, like, and stay signed up for the following one, so like you can watch what we will do next. So first, I'm gonna be position this webinar is still in the code section. Remember, Otto is about create, connect, code. Last one was about the create part. We had a special guest from Maker Senpai, where we did 3D printing in place. We designed stuff and we modify parts in Otto, and we like also address a little bit of design thinking and stuff like that. In the first one was an introduction, kind of like the connect part. We already talked about coding part in the second one, where we introduced the icons, words, and a little bit of editing the text for Python, MicroPython, of web code. But today we will go further. So it will be a little bit advanced or intermediate advanced, but don't be afraid to ask any question. We will try to have very simple language for all the stuff we are doing, because at the end of the day, this is for children. So like we are kind of like treating you as the educators that will give examples or activities that we will show today, and have to make it as simple as possible, because with Otto, what we aim is always have technology very frictionless in a way that everybody can learn, right? So we will go to the beyond the basics, basically what it says there. So with this, I will give a little introduction to our special guest, Ivan. Ivan from Dominican Republic. He's very close to us. He helped us develop all the lessons you see in our website. And he has been around the Otto project for around 4 years since we started the company here in the Czech Republic. And yeah, he has something very interesting to show us. So first, Ivan, welcome. Good to have you here. How's it going? How is the weather there in Dominican Republic?
Thank you, Camilo. It has been the typical here, like an eternal summer, we call it, because it's never cold here. So for most
Okay,
of your guys in Europe, it's probably the most enjoyable weather. For us, it's a bit of it
too
gives us
much.
a bit of cold here.
Oh, it's the
So
opposite.
everything
Okay,
is
yeah,
going
no.
good. Thank you for the introduction.
Okay, so I will be the one sharing the screen. So you will be telling me a little bit about your project. I will be first showing this initial video. This was the first version of your project. Can you tell us a little bit about what it
Yeah,
is
sure.
about?
Before the project, I would like to give a bit of context. Like probably like most of everyone in the world these days, ChatGPT, we all know this word, has become like my favorite digital friend these days. And it has shown us something very interesting in the last years. That is that computers are now not only tools, but there are also some kind of companion in our world and studies and everything. So thinking about that since let's say more or less 2023, I have been thinking how we can create a bridge between this generative artificial intelligence and the real world, like the physical world. So with this in mind, I start to make some tests and see like, okay, I can make ChatGPT or other generative AI to act as, for example, a professional developer or a professional writer of give it many different profiles. So with this in mind, I thought like, okay, maybe I can make ChatGPT to act like a robot, in this case, like Otto. Then I start to test prompts like, okay, you are a robot called Otto, you are 3D print made, you have this component, these motors, you can do this, you can do that. So when you interact with a user, you must to be curious and help him to explore the technology world. And with this, I start doing tests. At the start, it was like a bit complicated, but while the generative AI evolved, it has
Mhm.
become easier and more intelligent. So we have uh, bring to the conclusion of the software that we want to show today that is called RoboTalk. So in the
Exactly.
video Camilo was showing, we basically can see the first test where I get an initial prompt, like for example, uh, tell me about squares. So when I ask this, the robot start to give me answers about, okay, and a square is this, and it is like this other thing, and it can show us how to it can describe a square with movements. So it's basically RoboTalk becomes a bridge between the generative AI and the physical world through robots, where we can uh, chat with the robot and get an easier way to interact with its function instead of we like giving specific commands to the robot. We talk with him and let it to decide how he interprets our commands. So if we can show Camilo the interface of
Uh-huh.
RoboTalk.
So here we are in the interface. So I just connected with Otto via Bluetooth. There was an initial setup for you to know, for everybody, which we can share later because this is actually a good testing that we want to share with everybody, where I just connected an API with Gemini from Google. Very simple process. Just generate this key that allow us to kind of like use Gemini for what Ivan created. Then I upload the code, which is right here also via USB cable. And now I can do via Bluetooth. So I have this orange Otto. And like I connected via Bluetooth, and then I can just chat and tell what to do. Here, I think I need to refresh. So I will show you again how it's the process. So here is the Bluetooth. Then it's found as GPO talk.
Yes, when we enter in the interface, you will see the Bluetooth button in red, and then you need to connect it. When you connected it, Otto automatically generate the first message telling you who he is.
Yeah. So here we run a little script that is like a little demo, but then let's start to, for example, ask, can you turn on the lights blue? And then we run the script, and then it turned blue. It's very fast. Like, so right now it has the basics of these lights over here, the ones in the eyes. It has the motors. So we can also ask, I don't know, show us some moves. So it already suggests some actions even, okay, and then let's say, okay, let's do it, and now it's moving. So I think it's a very nice idea because it can create this kind of like learning companion conversation where I don't need to know anything of coding, but I can start to interact with the robot and learn at the same time how it behaves. So here, for example, it's already giving some nice hints of how it works, the robot, that later in the code, it's how it works, right? What other things we can try, Ivan? What do you think?
Okay, yeah. So, for example, in the test I have been doing, one of the most interesting thing I think we can have is that Otto can create the sequence of code by itself without we needing to tell him exactly what to do. So, for example, when we think about the robot describing a square, we need to think like, okay, the instructions are move forward, turn right or turn left, and then move again for 3 more times. So it will generate the square. When we ask Otto through RoboTalk, move as a square or tell me about squares, Otto will interpret this like, okay, he's curious about squares, and probably he will want to me to move as a square. So the robot interpret this and generate the code. It's important to notice that with every answer of the robot, or almost with every answer, Otto generate this run script button that is basically the function that allows us to make the move. So basically, when the AI model generates the answer, it is generating a sequence of commands depending what we ask to the robot. So for example, in this case, Camilo, can you read us the answer from Otto, like what you ask and what is the answer?
So he's saying like, oh, excellent idea. To move in a square, I will need to move forward, turn, repeat 3 more times, then return to the starting position. And then it gives us the code. So it already gives like the algorithm, basically. It teaches a little bit about how the basic logic of coding with the response, which is what I like the most. I like not that just you can run things on Otto via simple language, but the fact that you can kind of like still learn the important things of coding. Because one of the things I wanted to talk today is probably many people will ask if like it's really important to learn coding now that you can do these kind of things. What do you think, Ivan?
Yes, definitely. So can we see how the robot do when we run the script?
Yeah, so I run the script and it's a square. I just have to move it because otherwise it will fall from the table, but yeah.
Exactly. So here is one of the important things I would like to talk about. So since we asked to Otto to act in some way, we who has experience with robots know that not every robot is the same. Like for example, here I have 2 different HP Autos, but if I run the same code on them, they will probably act a little bit different because motor configuration can change a bit, or one motor is too tight in comparison to the other. So in the real world, things don't work exactly the same for every robot, even if the robot is basically the same kit. So one of the interesting things with this AI tool is that now, if I ask him describe a square and it is not doing it in the specific way that I want, I can continue chatting, and with a natural language, I can explain to the robot like, oh look, maybe you are moving too much forward, or you are turning too much or too little. So we can fix the code through natural language instead of going to into this coding things where I need to say like, okay, the angle is not so much, so I should try these new values or etc. So there we can see how the robot
Yeah.
is describing
So
again, and
it's
this is
not
one of the most
completely 90
interesting things.
degrees, for example.
Yeah,
So that might be related to what you're talking. So maybe like it's thinking that it's moving 90, but the calibration in these motors are different. So like it needs to then have some iteration here. So could we ask, for example, the angle was higher than 90? And let's see if it tries to fix that. So, oh, well, first it's asking something. Could you give me a chance to adjust my code to more accurate 90 degrees turns? I will need to test and fine tune to get it just right. I'll let you know when I have better solution. In the meantime, we can try other things. Okay, so this is already reaching the limit of how you train the model.
okay.
So we can, for example, tell to change the speed when turning. So that one, no. So then we can ask the time. The duration is already suggesting. So for example, I was already suggesting some stuff that was limited by the training, but then it already suggested things that I can use. So duration, short-term duration, yeah.
Yeah, so that's one of the nice things. Now we have a new kind of relation with the technology where we can learn from it, and in this
Mm.
interaction, we can learn new things, but the robot can also start to understand us better.
Okay, so let's try that one. Okay, it's a little bit still, but I can see that it's different and less stiff. So we could
Yeah,
continue iterating like this, of course, but I think
yeah,
the
it
principle is
will take a
clear.
process. So uh, here is
Yeah.
one of the most interesting scenarios where I imagine using this kind of technologies that is an educational setup where, for example, students can be doing some robotic classes and they could reach a difficult challenge that they maybe don't completely understand how to solve it. So they can come to RoboTalk, chat with the robot to try to understand how they can fix their code or how they can complete the challenge. So for educators, I think this can be a very great tools to explore in classrooms and their robotic classes.
Let's try with lights. So show me.
Yeah, you could
Oh,
try, Camilo. There is an interesting test that I did that not always work because we also know about this term called hallucinations in AI models that sometimes it creates data that is not completely correct.
uh-huh.
So, Camilo, one thing that you can try is to ask, for example, tell me about a specific country and show me the color of the flag of that country.
Colors in the lights. So France is gonna do French flag. So we will respect blue, white, and blue, and then we can run the colors. I will move here to see. So
Okay,
blue,
yeah, we see
yeah,
how he turns one eye blue, the other eye
yeah,
white, and then both eyes red.
yeah, yeah. So it kind of
So,
got it.
so here you can start, like, for example, to say the same color of the French flags is actually the same color of the Dominican flag. So we can
Mm-hmm.
start to add with Otto, like telling like, oh, but this is also the color of Dominican flag, or maybe asking which other countries have the same colors. And
Mm-hmm.
we can start, like I said before, learning with this tool, and it made the robots to become, I think, a truly
Mm-hmm.
learning
Mm-hmm.
companion because now we are learning together.
Okay. So you can involve other topics. No, here it's not
Yeah,
suggesting a specific one. He's saying like it's iconic, like not another one that have exactly the same colors. Maybe meaning even the position.
Yeah. Yeah, exactly. Like in some
Okay.
flags, the positions are different.
So like maybe I asked it wrong. Like I should ask which ones use the same primary colors, not like if it has the same order of the flag.
Oh, yeah.
Okay. Well, I think it's good demonstration of this. Thanks, Ivan. I will come back here to the presentation, and we will go back to you once I'm pretty sure people will start to ask questions if they are not already about what we just showed. We will
Cool.
come
Thank you
back
so
then.
much for the time.
Yeah. Um, so to continue a little bit with we have been working. There has been these extensions that maybe many of you saw last year when we did the first webinar with the teachers. Now pretty stable. You can give it a try. Here we will be very quickly to show some of the things you could do. It's mostly machine learning interaction of AI with the computer. So these are stuff that works under the Scratch platform. And for example, here we have a set of cards that we can use with the computer to kind of like have some sort of tangible coding experience using the cards and the machine learning that it's incorporated in the extension. So things like this is already possible for the ones that want to try it. You can also access actually from our website, but it's a little bit hidden for the beta part. These are some of the extensions I mentioned. So face recognition, object detection, human part bodies. So like students can play with their hands. I have different stuff, not only to kind of like program the robot, but have different interactions with the robot. So you have something in the camera, you show to the camera, and then the robot react to that. Here are other examples. Like you can have also things in the screen, like traditional Scratch that you create video games and stuff, and you can have them interact with the physical robot. So you can do things like this already with the cable or with the Bluetooth. So we can create some little games in the screen, and then the robot kind of will show some signals, or will light up, or it will move depending on what is happening in the screen. This is the face recognition. So a good example is like, okay, if you are smiling, then in case here we are using the emote expansion, then Otto will smile. If you are sad, then Otto will be sad. So things like that already possible to do with Otto. See. And I think that wraps up the first part of this webinar. Here is the pose detection, so you can have also your hand and wave it in the front, and then have different reactions there. It will detect all the fingers, and the model is already trained, so you don't have to like do that work. It's immediately trained for the hand detection. But we also have teachable machine, which you can train, and like for different objects that maybe not included in the app, and do these kind of interactions with the physical robot. So here's the teachable machine. But we will jump now to the Q&A part. It will be like maybe 5-10 minutes maximum, depending on the amount of questions. So please write them down in the chat. I will jump and start to read them, and we will see what do we have. Let's see if there's any question. Okay, so Leo say hi. Hi, Leo. Mm. By the way, there's also a poll there. I see that already 3 people answer. Like, and you go to the chat and you can find what is your favorite topic for today. So today we are doing AI, IoT, and Python. You can answer at the end. It will be good for us to know what to focus on the next session, even though we will do a little bit of something else, but we want to do the connection of what we are doing today with the next one. So I don't see any question. If everything's clear, then we can move on. So like we can show more stuff. You are still free to ask any question. We just wanted to have that as a little gap before we continue. And we can jump to the other topics if nobody has a question. So I wanted to show you guys today something really brief about Internet of Things. So it's a thing that we have been around with Otto. There's already the blogs, but for the people that don't know what it is about, it was a topic that was also very trendy before AI, and it kind of like, I think it faded away quite a lot, but it's still relevant because today with AI and all these tools, all these robots, internet, everything, it's becoming interconnected, and it is important for certain applications to know how it works, all this technology. Actually, many of our educators like this part a lot because they can teach about the weather, they can teach about like how to create different systems to track the sensors, especially you can have a dashboard and see what is happening everywhere in the world, control one robot that is in the other side, interconnect them, and create all kinds of applications. So the first one is the NTP, which is Networking Time Protocol. I have an example here, which can be done with the starter as well, but I have it with the expansion here matrix. But what I will use is the LED ring. So because Otto has a Wi-Fi, I'm connecting this robot to the local Wi-Fi here, and I'm getting the actual time, and I'm displaying in the color ring. So for example, the red one is displaying the hour, the green one is displaying the minutes, and the blue one is displaying the seconds. And you will see that it's actually moving. I think I have it with a different like time zone, but I can adjust it. I can right now, it's supposed to be 3 and it's at least 2 hours behind. So it's showing 1. But you get the idea. So like Otto connects to the internet, gets the time, and I can display it here. And that's the same principle for everything in IoT. It's basically, you have a set of tools online where Otto can kind of communicate and get that. So we have, for example, IFTTT, if this, then that, is like a very common one where you can, with simple conditionals, for example, if you can do it in both ways, either like something that you got in the robot, if Otto detects something, then send me a message or send me a notification, send me an email. So you can connect every device that somehow has Wi-Fi or has some sort of online service. Like we can connect it to Otto. Now, I want to clarify that all of these apps are independent, and that's maybe the thing that like why not many people use them is because it's a third party. So we are connecting to third party, all of them for free for basic stuff. But for like examples in the classroom, I think it's perfect, or at home just to have fun, to have something personal as well. Like for example, instead of getting the time, I could get the weather and display it in a screen, or it will just put it in the robot, like through serial. I will get the information. There's also a Telegram, for example, so you can get a chat if something is happening, and other ones like ThinkSpeak, which is like a complete dashboard for that. So I will give you a quick show of how they look in the blocks. So in the blocks, if you go to IoT, in the IoT, you have the blocks for connecting through Wi-Fi, right? It relies on the internet, so you need to have the password and the username of the router. This is the NTP, so this is how you get the time synchronized with the clock that Otto has inside, and then after we get that information, we can use it to display in RGB lights, or we can use it to display in a OLED display or on a matrix, or we just use it for other things, right? And all of them, as you can see, work based on an API, very similar to what we did with Ivan. So you need an API for these third-party apps to kind of like have the key for Otto to enter and be able to get all that information, or to send the information. So to receive or send the information. So as I mentioned before, this is quite like already intermediate advanced topic. but we will be doing a lot of materials to make this much easier to digest. And we already have the blogs, which you can play with them. You have the previous ones that I showed. You can also do emails. The open weather is really nice. Like you can get the forecast, the full forecast, and then the best will be displayed in the LED matrix, but you can also use it in other things. So this is about IoT, very brief. We could do something more deep in depth, like in another session, but just for you guys to have a little grasp of how it works. Now, this is one of our favorites now. We have been doing a little bit of vibe coding with MicroPython. For the ones that are not familiar with the term, vibe coding is a very new term. It just created that now with applications like ChatGPT or any other LLM model, then you can create codes very easily. And because Otto is based on MicroPython, which is based on Python, there's a lot of things online that we can leverage. So for example, we created a Pong game in matter of minutes. So we talk to ChatGPT or Copilot or any other, and with a basic prompt that I will show you, we will do it now. You can start to create your own games. Here we have some examples. I mean, you can create other codes, but we thought that the games are the best applications. So for example, here we have a little menu that I can scroll with the encoder that we have in the Interact. I'm using here a little module that you can 3D print as well. We'll have it on our website. And thanks to the encoder, we kind of like browse into this kind of like little game console. And we so far have created like 5 different games. So let's try, for example, this one. I have a button here, and oh, I lost. So I will restart. I have to be faster. So we will try that one. That one was Arcanoid. So Arcanoid, for the ones that know, is this little bar that has to move from left to right, and it has to break all the little stuff. And this was created like very fast. Like, of course, then we refine it, added some score, some leveling, and I will show you how we did it, how we did something similar. If you have any game in mind that you would like us to try, we can improvise and see what we come up with the byte coding that I will show you. Yeah, here. So I lost. We also combine it with the LED matrix. Patrick here did this nice Tetris game. So here we are combining 2 matrix to make it longer, but we also tried with one and it works nice. It's just a little bit more difficult. But when you have here, then you can scroll down and you can like also rotate the parts. And just start to play the classic game. And here, I think I'm a little bit bad there. Oh, so yeah. And then anybody that wants to try this, if already has the components, then just can write us in the community and we will share with you all of this stuff. And this is stuff that we will be adding also to the website, like for you to try. But I will show you how easily you can generate this with a little bit of vibe coding and MicroPython. So yeah, coming back here. So what we're gonna do is like to frame it. First, I will need an IDE to communicate with the Otto. So I need, in this case, it's not Otto, but this device that we will use. I know where things are connected. It's very important. Okay, and then we can try. So a good idea for this, because we are not going to do block coding. For block coding, I don't think there's a ChatGPT now for that, but we go directly to the text coding. So there's multiple ideas. I think we showed you before. Tony IDE is one of them. It's a little bit more advanced. Arduino has its own IDE. You can see it here, Arduino Lab, which I can also use. But we also have the one in webcode. So for the ones that remember, in webcode, you have the Python mode. And here, I can use this one to communicate. So let's try it on this one. First, I don't know, let's jump to ChatGPT, or if someone has a recommendation, we'll start a new chat. So the simple way to do it is, okay, what microcontroller I have. So I have an ESP32 in Otto. And I need the MicroPython code. So those are the two key words that it will use. So I need code to, what we'll try some game, or should we try some demonstration to say hi to webinar participants in MicroPython for my ESP32 in an OLED screen display. So I'm already telling him what component I have here and what is the microcontroller. And we will see what comes out. So we are going to try something basic first. Yeah. So then you can see that I already picked up the display driver, and this is a good one, and it's connecting it to I2C. It's already telling us the requirements, like how to flash it, so we can use our IDE for that. The size of the screen, which is a very generic one, so it usually gets it right. Here it's suggesting 64 or 32. We have the 64. So yeah, you need to know a little bit of the basics, but let's see. Here is suggesting the driver, and here is the code. So we can try this code. We just copy, and let's go here. I'm gonna connect, I'm gonna pair it. We're connected via USB, and we just paste it. So here we have the code. I might have it connected in different, or I will switch it. So here is suggesting the number 3. The number 3 has the encoder. So I will switch this briefly here. I can as well move the pin better. So if it's in the 1, I can better just change the numbers here, 18 and 19. And let's play, see what happens. So there it goes. I have it with the cable because I don't want to delete the games that are saved there in this camera. So you notice that I only changed the connectors. That's the things that usually you have to be careful. But the rest is like pretty straightforward. Like already these systems are trained for that. It's a very good way to get into coding and try even different things that maybe will take a lot of time coding. And that's why it's like Vibe. It's like very relaxed way of coding. And I can continue here. We can try something more complicated, for example. So here we can disconnect this guy. So maybe some animations in the display. And I have a button in the, let me see, it's in the number 10. The number 10 was the 13 pin. I don't remember. I need to check. And I have a button for, and we can tell for changing images. I don't know, or changing graphics or shapes. And let's see what it comes out. So I will try to do some bouncing square, circle, triangle, a button to change them. Okay. And then it gives me the new code. And then again, like, oh, it's still creating it. So we have to wait a little bit. If I copy it now, it won't be complete. So it's creating all the different geometric shapes. It's doing some trigonometry even already. And the button with the buttons. What I will have to be careful, like I did with the display, which I forgot to tell it to change. It's connected to the 14, which I don't remember if it's that one. To check. Let's see. So I could have used also this one, for example, this IDE or the Arduino, but this one is more straightforward. So I delete the code I had before. I'm still connected. I need to change this again because I have it connected in a different port. And for the button, I do know the 26 is this one. So I will change to 26. And let's see how it works. So we see the cube bouncing. It was very fast, you could see. And then with the button, we can change the shape. You can see on the place how we use AI to create quick codes to interact with different components of Otto. So circle, the dot, increase a triangle. This is like a bouncing code, different stuff. And we can go on from there, like, and create more stuff like the games we created, the Tetris. For example, yesterday, and giving a little bit of connection of the other AI, like for generating images, we created this cube. So, and again, we use AI. This one doesn't use the screen, and what we do is like, it's like the Simon Says game. If for the ones with my generation, like you have to follow the sequence with the different buttons. So we have 4 buttons. We have the green, the blue, the yellow, and the orange, red. It will be red here. And we just have to follow the sequence. The lights are displayed in the same coloring that we have in the starter kit. And then as I go, it will show me how many I have. Follow. It's using the buzzer as well, which will also ask the AI to include. So 2 times the yellow, red, yellow, continue there. Now I'm in level 4 or something. And continue like that. It's a very like dynamic game. You can see here that we are using components of Otto to build other things different to robots. I almost forgot that one. I'm probably gonna lose because. So now you can see with the red. Okay, fine. So this is a very fun like example to show the capabilities and to create different games. I make the mistake there and I can start again. There's a multiplayer way that like I can play and between 2 pass it along. And with this little contraption we created here, we're gonna have a little fun, like creating all kinds of different devices and activities that maybe you can pass along in the classroom and create like a hot potato or like an accelerometer to different positions with the matrix, and then you have to balance it. So we can create different projects with the same components of Otto and with the help of 3D printing and create totally different devices. Before we show like the little jigs and stuff that you can create, but this one is like taking it even one step further, like creating different dimensions, and with 3D printing we can create endless stuff. And these are files that we will have online available for everybody that has an Otto, and so like you can also try it in your 3D printer. What else we have here? So in the last 10 minutes, I want to first show a little bit of what we have been creating in terms of prompting. So this one is also a very good example of how to use AI to leverage a different topic. So before we're doing code, now we will do like great design or ideas, and then later we can 3D print. Now there's no like a good AI that we could say, oh, create that Otto and give me the file for 3D printing. Like they are quite far there yet, especially since 3D printing need to be accurate. But for inspiration, and then taking this to, for example, Maker's Empire or any 3D software or preference, it's very nice. So for example, this Iris Otto, we basically generated the idea in AI, and then later we replicate it in our software and make a very similar one. It doesn't have to be the same, but it really helps to kind of like have the right inspiration and new things that you wouldn't think of. When we created Santa, for example, it was us like forcing ourselves to find a way to make it, but with here we can get very good inspirations and create stuff. So And the best recommendation for that is to use an image as a base and then start from there. Because when we, for example, were just telling the AI to do from the words, it will create things like this, But when it had the image as a base, which was something like this, then just telling a little bit of the style we want, a little bit of retro vibe, and like the 70s kind of or 80s style, retro futuristic, then it creates those kind of things. Otherwise, if it was just simple words, it will really go too free. So it's good to put a little bit context in the AI, and that will help to. You can see how, for example, this one evolved. It was first something like this, not something like this. It had legs. It tends to put a lot of legs in the robot. So then, like, even if it has wheels, it will put the legs at the same time. And sometimes it goes for things very abstract. Like, so it is important to give it the base image, which you can find online. For example, grab it from our website and then just put it there, and then start to create all this kind of crazy stuff. For sure, some of them are like really difficult to replicate in real life because it has extra texture and stuff, but it gives a lot of ideas of things that we could do. And I think it would be a very fun exercise with students or with kids, like that they what would they imagine and then try to replicate it in the 3D software, right? So this is something that we have been exploring a lot, and we have been creating all these versions. The latest one was this Oktoberfest Otto, which, yeah, we started with an image like this. And at the end, we were like, okay, we will do it ourselves. But then if I take a photo of it, I can then use it to expand on it and maybe create like a story behind this auto with the Oktoberfest, and it takes some freedom and even give us idea. Oh, maybe the hand can be better if it's like this instead of this one. And then you can create graphics and stickers. It likes to put also hands on it and and like a belly and stuff. But yeah, like that's the fun of it. For this one, the prompts are very simple, as I said. Like, for example, if we grab some of the stories I have here, just like give the raw image, and then if we can make like a 3D render of this one, and then like so I invite you to try that and maybe share with us, right? It tends to put the wheels very thick, but you can tell, okay, change it, and just have an iterative process. It's very good. Can get to things like this. So that's about for today. I want to check if there's more questions, and if not, then we just give a little hint of what is coming in the next last webinar, and then we can wrap it up. In case that you have, of course, questions later, this will be recorded, and like you can always email us if you have any additional fires of what you would like to experiment by yourself. So I don't see any questions in the Teams. Is Ivan still around? Are you? Or he?
Yes, I'm still around here.
Okay. What did you think of what we show at the end?
Sorry, can you repeat the question?
What did you think about the IoT, the vibe coding? Do you have similar strategies, or because you have been implementing something like this, you told me before, which one did you like the most? Which one do you see potential? Since you have also an educator background, you do the WRO and you teach students. What do you think?
Yes, finally, like for example, I'm using a lot of vibe coding, especially to try new ideas or find ideas that maybe I haven't think about it before. So vibe
Mm-hmm.
coding, I think, is a pretty cool tool. It still need a lot of behind work sometimes because it's difficult to give all the context to AI when we are prompting ideas. Like for example, you were talking about specifying the which language we are using for coding. In this case, MicroPython, where are things connected to in the pins of the controller. So vibe coding is a pretty cool tool to try, especially when we are starting to explore the programming world. So in competitions like World Robot Olympiad, we are seeing kids that are exploring ideas already through the AI. So yeah, it's definitely something very cool to continue exploring.
Okay. Well, good that you mentioned the WRO because the next webinar, we wanted to emphasize on all the fun activities that we're creating with Otto towards a future competition with the robots. So as you have seen already in the other camera, we created this map that can allow you to do different activities. Now, this is just a little concept. We are evaluating different parts. It's a simple line following map, but at the same time, you can do sumo battles and you can do different activities like or challenges like go from A point to point B. Maybe we can add some objects that you can pick with the new invent expansion with the gripper. And we also wanted it to have like a football. So for example, if I put these ones here, but for the football, we have a surprise for the next one. Or in case that you are in the WRO final in German, which we are going, we will present all these games that we are creating around the robot. So this one is
So
quite fun.
You will be showing this map in the competition of Germany, the WRO final in Germany.
Exactly. We will have a stand right there, and we will have this map, and we will have also the surprise football one we have up there, and also all these customs editions. Of course, the Oktoberfest Otto has to go because it's very relatable. I wanted to mention first that actually we were exploring more like the flags colors for the Otto, but we think that this direction of really cultural garments and like related items for the Ottos make more sense. Let us know what you think. Like if we should actually continue with doing the flags combination, even though with the flags combination we reach a limit, and it's usually for the flags that are like in 3 levels. Or because if you want to do horizontal, then you have to do multi-printing like this, and it becomes very complex. So we are exploring a lot of this. We also had the Otto Santa and other ones that we were designing. And just yesterday and today, we printed these sumo Ottos with some very nice eyebrows.
Yeah, a bit more aggressive expressions for battle.
Yeah. We are missing some bumpers, which we will have them for the next webinar. And we will show you how we did it, what codes to use, how can you prepare something like this, what tools are needed.
If you want, I can show some of the bumpers that I already printed for testing sumo.
Exactly, yeah, there you go. Yeah.
For example, here I have this one that is help the robot to push other robots out of the...
That one is really good, yeah.
Yeah. And this is more for moving things around. Okay, easier. So moving things around, but it can actually also work for both robots to try to push each other from the map. So these are very interesting attachment to test and to create different strategies. Like especially in competitions like sumo battles, it's important not only to have the right attachment, but also to have the right code to use that attachment. Because, for example, it's not the same an attachment like the first one I showed, that it's more based on the force, it's more based on the center. Like the second one that you can use the corners to move the robot, turning it around, so making it move different. So it's pretty interesting to explore different attachments for different strategies in game.
Yeah, that's why it's a good activity because it kind of combines the 3D printing, the coding, and like all the logic that we have been working on. So, for example, here is a very simple code that actually is from you, Ivan. You sent to us before, and it has this like searching, So now the ultrasonic is waiting for something to come close to attack it, to push, and it doesn't go out of the ring.
That one is one of the most basic sumo strategies. Just move around, find an opening, try to take it out. So, but someone could take a different approach, like moving around the map and searching not only
Mm-hmm.
by turning around, but like looking forward or backward or different. So that's one of the pretty cool things about robotics competitions, and it's pretty nice that you are already thinking about exploring with this kind of game fields that I can notice is pretty multitasking. As you mentioned, it has sumo, it has
Yeah,
soccer or football, and also have these different spaces with letter that could let you to make missions. Like, okay, take this from point A to point B, for example.
exactly. We will wrap it out then with a little fight here. The two are programmed with the basic search and push. So let's see votes on the chat. Let's see who wins. So they start and now they will try to search each other.
Oh,
Oh no, this one went
yeah, the
down.
second one got out. Yeah, my code works better.
Round two. Why am I starting them looking like
Yeah, that is something that we do. In my case,
behind?
I create competitions, and one of my works is to create the rules for this competition. So to make
Uh-huh.
it the more fair possible, one thing that we do is randomization in the beginning. So the robot can start looking in front of them or back, or one looking to the left and other looking to the right. So it's make more interesting the code strategy.
Okay, let's turn it on again. Let's see. Okay, the blue one seems
Yeah.
a little bit scared. So red win. And with that, we wrapped up this. Thanks everybody for that join us. You will get the recording after this, and tomorrow we will publish the date for the last webinar. If you have any suggestions, let us know. See you in the community, and or see you in one of the events that we will be. Well, we already announced the WRO event. We are gonna be in Maker Faire Rome. Is confirmed. So premise for you guys that join in October in Italy. Yeah, see you there. We will have also a stand. We are increasing a lot of games and a lot of things. If you have any suggestions, then let us know. And have a great day. Bye.
Thank you. Bye.
Thank you, Ivan. Ciao.